Awesome! Just thought I would do a video and show you what I've been up to. The latest one is printing a holster for the batteries. So they're spaced out to allow air to circulate, and hopefully if they start heating up, and heating is a problem, I can put a fan on the end and blow air through the batteries, out across the dome, and then out around the outside of the case, and then maybe back through this metal pipe here, plumbing pipe, to act as like air conditioning, cooling the air down and hopefully condensing any moisture inside the pipe. So I'm not 100% sold on that idea yet, but that's what I've got. I would also notice that you could the whole ROV would actually fit inside a piece of acrylic still, so you know, you could have acrylic with a printed end cap, ROV guts, and then not have this housing at all. But the housing was only £40, and seems nice that you can screw the O-rings together. There's obviously a huge O-ring on this end, it's quite easy to take apart. As far as I've got with the ESCs, just like you saw in the last video, printed holders there, and then just printed off another piece here. Took a while to print actually, I was surprised. It just slits in between the fins there, holds it together nicely. Yeah, I was thinking if you print this piece off, you can maybe put a piece of acrylic in here or something, because it is a bit flexible. And obviously it took a long time to print, and because the printer bed is quite warped, kind of lifted off even with a big raft on the bottom. And it's twisted a bit, but yeah, so still to do. I need to find some way of attaching these battery connectors, ESC connectors, in here somewhere that I can remove them, and so I can separate the ESCs from the power supply, but also I need it to go through a current shunt or resistor, or maybe through the ACS 712s current sense doofers. So that's, and obviously there's a lot of insertion force in these connectors, so it'd have to be fairly robust. I'm guessing like a common ground through them all, and maybe you could solder a big bit of brass on here or something, and then cast it in fiberglass, maybe something like that, because I think if you put it on circuit board it'll just break pretty much straight away. So that's still to think about. And using these bullet connectors in the back here, I like the same ones you get with the ESCs. So what I've done here is spun in the through-hole connectors, same as the other videos, just Arctic Flex with the insulation stripped a little bit in the middle, opened up, and then all taped up in this plumbing fitting, and then spun the whole lot with resin to get the resin to go into the fibres. And then maybe also add some liquid electrical tape over here and over the joints as well, and that'll add like a double seal. Ideas for that, and obviously it's a bit easier to connect to than having rods going straight through the resin. If they're just wires, obviously you can turn corners and stuff. There's a bit of a faff getting it through this plumbing fitting, but it kind of works. So we've got lots to test. I'm kind of almost ROV shaped, which is encouraging. I've still got quite a bit to do though. So the opener off control board with beaver bone black should go in there, and then China started to sell this. It's a synchronous buck converter, which is good because I haven't had one, couldn't find one that done 48 volts, and this one goes up to 60 volts input, so the tether will come in into the buck, and it'll step it down to battery voltage, which is like a 11 volts if it's charging all 3 cell groups. We're also hoping to have a bank of switched MOSFETs, so that can switch the input from this either to go through all 3, to go through 1, or to go through 2 individually. And then have a resistor switched in here to the constant voltage. So take out the constant voltage pot and then have a resistor switched in, so that this will act as a charger for the batteries. So as it switches in the resistors, it will output different voltage, and the voltage will be dependent on what MOSFETs you have turned on and which cell group will be charging at any one time. I'm thinking about having 12 parallel and still having 3 in series, so I'll use 2 of these carousels. 12 around the outside will be group 1, 12 around the outside of the next one will be group 2, and then the 6 in the middle of each carousel will be group 3, and then there's space, probably leaving this wire here for connectors and wires and stuff running through. And we should be able to balance charge at 10 amps. This is rated for 10 amps, and it's probably possible to increase the size of that inductor and parallel up the N-channel MOSFETs there if you want more power, because it's 150 watts if you want. And then we probably just need to change that shunt resistor there to fool the chip into thinking it's less current than it is, because it's current limited to stop the smoke being released. But that's yeah, pretty exciting, because it's a lot smaller than I was thinking it was going to be. So that needs to go in here somewhere, and we still need to get the switch in. Anyway, yeah, the Ethernet switch, current sensing, and then that's us, I think. We'll have a ROV, and then yeah, that's the servos and wires and stuff to connect up, and lights at the bottom, and a separate module at the bottom fed through wires through the pipe. I'm sure there's other stuff I've thought about, but that's where I'm at. Hopefully I can have a little play with the batteries tonight. We're going to assemble a decent pack from this, which will have very little airflow, to something like this, which will free up some more space. So yeah, one day we'll get there. It's all good. I'm enjoying the process.